Okay, so homework was we had a stack one, right? It was the 2.4. Consider the data type of stacks of values with an interface consisting of the procedures empty stack, push pop top, and empty stack. Write a specification for these operations in the style of the example above. Which operations are constructors and which are observers. Okay, so in the style of our whole empty environment, apply environment, that's the style they're referencing. So we think about how might we represent an empty stack. Let me get I already have it open. I'm going to leave this for now, our implementation of that. So a stack in Scheme is probably going to be a list. So empty stack, empty list. Like that. And what we call that guy a constructor. That constructs an empty stack. Okay. So we're kind of connecting back to our programming languages that we're familiar with and trying to understand some of these underlying concepts and how they work. So an empty stack is going to be like that. What else do they want us to do? They want us to do push pop top and empty stack. So empty stack, let's write that first. That's a predicate for that guy, right? And this is going to be a lambda that takes in a stack and returns null stack. Look reasonable enough? Okay. Now, when we think about our stack data structure. When we push something onto a stack, what are we doing? If we have a list representation, push puts it onto the top of the stack. Where do we want the top of our stack to be in Scheme? It probably would make sense for it to be the beginning of the list, the front of the list. Okay, so define push to be a lambda that takes a stack and an element or a val, and cons is val onto the stack. Something like that. All right. What about pop? What does pop do?
Takes the first the thing off the top of the stack and returns the rest.
Okay, so takes basically returns everything but the top of the stack. And so, in this case, you probably could have taken some liberties. I don't know if there was some reference farther in the chapter. But when we think about pop versus peak in a traditional stack implementation, we kind of like pop, remove something from the stack, and usually actually returns that element. Peak returns the first element, but doesn't actually remove it from the stack. Because we don't really have a direct environment we're working with here, it sounds like your implementation of this was give us a new stack which has everything except the first element. Is that a fair enough implementation? If you did it differently than that, that's okay. This is more of the exercise of working with these constructor things. So define pop to be a lambda that takes in a stack lambda and returns the coder of the stack like that, and then peak is a lambda that takes in a stack, returns the car of the stack, first element, but we didn't actually remove it from the stack. But also we're not working in an environment, so it doesn't necessarily matter if we've returned it or not. So is this kind of a reasonable implementation for our stack? If you deviated from this a little bit, that's okay. I mean, create something that's stack-ish. Go ahead.
So we had a disagreement on pop do you believe that it's a constructor or an observer?
Well, okay. Depends. This implementation, it would be a constructor.
I win.
You win.
No, you did not.
Fight! So in this so let's follow up that. Why is it? It's a constructor because ultimately what it's producing is a stack. It's producing the underlying element. It would be an observer if your implementation of pop gave you the element that was at the front of the list, effectively working like peek works here. Does that make sense? So I don't necessarily care. I mean, you
I
know,
don't think so, just curious.
yeah, it's and I'm usually like that with homework assignments. I mean, I'm more picky about situations where you're like using tools that you haven't previously been given and stuff. If you take some liberties on an assignment, as long as it's not like an unreasonable liberty, like here's somebody else's solution, and it's not the right solution, but it's a solution, or it's written in a different language, that kind of stuff. So as long as you've made reasonable things that looks like you've learned something from the assignment, I'm not picky about it. So if you, I suppose you could probably make a roundabout argument. I don't know what it would necessarily look like, but you could maybe say pop is an observer even in this implementation because you're observing the resulting stack from popping the first element off or something like that. So I don't know. All I know is if you wrote this implementation and you said it's an observer, you're going to get a 0 in the whole assignment.
Yay.
All right. So now, other one I here was more difficult. Shouldn't have been. Tim was whining about it. Just an embarrassment, really. All right. What? Speaking of which one is it? 2.9? 2.8? 2.9. Add to the environment interface an observer called has binding that takes an environment env and a variable s and tests to see if s has an associated value in the environment. Okay, so it's just returning a true or false?
Yeah.
All right. And is this the environment implementation that you worked off of?
I just went off the one we did in class last.
That's fine.
You constructing class.
So why don't I do this just for, I guess, completeness? Why don't I go ahead and bring their interface in to my code and we'll just implement off of that so we're kind of consistent? Yeah. I mean, really, yeah, it's the same as apply env, right? Except that actually you can probably implement it in terms of apply env. So I'll just steal all that and we'll doctor it up a little bit. Is everybody happy with? Well, let's. I don't know. Do you want to use theirs or you want to use mine?
Yours.
I can't decide. Let's use theirs just so it's compatible with the future assignments, even though I like my implementation better. Okay. So to there, and that. And I don't like all these stupid error message things. Does Scheme have a fixed indentation, or Dr. Racket have a fixed indentation dealie? Okay, and we need to fix some of these dudes. All right, so the empty environment is a list containing, well, that's actually the same as our implementation was, isn't it?
You ended up switching to theirs again in the last class.
Oh, okay, I got it. Oh, because the difference was the words, right? Yeah, okay. Well, whatever. We'll just use theirs here. Extendenv takes a var, a val, and an environment, and we return a list containing the word extendenv along with the var val and then the environment after it. So it encapsulates the old environment. So you can think of that like scopes. In fact, I'm sure that's kind of where they're going with this. Emptyenv takes in an environment and the thing we're searching for. And this guy's using, I think I mentioned the cond at the end of class last time, which is effectively a replacement for it. It's equivalent to a switch statement, which I typically don't use very often in modern programming languages. But if you have a situation where you have a whole lot of like if-elses, a cond is kind of a convenience structure for that. So this is just a conditional, hence cond, conditional. All right, so if we're looking at the empty environment, they have a little function down here, report no binding found for search variable. That's this guy, and then it's just a stupid error message that'll pop out. I'm not a big fan of pumping out the error messages. I mean, who writes errors in their code, but whatever. It was supposed to be a joke. So now it's like pathetic. It's like Dr. Locklear having to tell you to laugh. It's like, okay, everybody laugh. At least it's not on the slide. If we're looking at an extended env, then we're going to go ahead and create our let, which lets us create a kind of a local environment. But the default let, we have three different lets. We have let star, and we have let rec. We don't know about those other two yet, but let star allows us to have, you can define variables in terms of other variables in the let. And then a let rec allows you to make recursive calls within the rec let environment. But normal let, if you can't say let a equals 5 and let b equals a. You can't do that. You can't have variables defined in terms of each other inside of the let. So that's the kind of the deal we're dealing with right now. So we're going to have our saved var, which is going to be the variable that we're the catter of the environment. So that is the name of the variable that we're currently looking at. Not necessarily the one we're searching for, but the one we're currently looking at. Here's the value of that variable that we're currently looking at. And then here's the environment, the inner scope, the next environment that we would search next in there. All right, so that's the end of the let. Now I'm going to actually kick this down a line here. So this is the body of that let. This is kind of weird. That. So if the saved var is equal to the search var, and this is maybe a new thing we've seen here, since our variable names are all symbols, we can actually use the equal sign. Actually, can we use equal sign for symbols? I believe so. Or does it just work for numbers?
I think it just works for numbers.
So you could get away with just EQ then with them. Then we have EQV, and then we have equal. Equal will always work. But it's like, it'll make more sense later, but I usually say equal kind of looks at bone structure of it. But we'll just leave their implementation. So we want to know, is the search variable, the guy we're looking for, is it equal to the guy we currently see? If yes, go ahead and return its value. We're resolving the variable. And we have found the most local occurrence to the variable, and there's its value. Otherwise, we're going to go ahead and recursively call apply env, passing it the variable, the environment in which the next environment to search, along with the variable that we're searching for. Okay. Else, on our conditional report, we have what you gave us isn't a legal environment, something like that. All right, let me go ahead and run this real quick. I just want to make sure that the EOPL thing exists.
Oh, you didn't change the...
Oh, thank you. Because I think that EOPL thing is only available, yeah. It's only available in one of the languages. because that's the essentials of programming language thing. Did anybody get the EOPL thing to work? See, this interpreter used to be associated with the book, so they used to have a language for essentials of programming languages as a choice. It's possible there's a teach pack we can get for it. But whatever, I think it's stupid anyways. So let's just return false.
I think I'm able to work without, if you just take out the EOPL and the, just take out all
And
that.
just say error?
Just say error, yeah.
I think you also have to take out the little tilde s thing in there too.
Oh, that doesn't, it won't let you embed the
Well, I
string.
think it'll show up. It'll show up in the output.
Happy enough with it. I don't care if it shows it up or not. I just want to make it happy. I don't care about the error messages. Okay. In fact, if I were writing this, I would probably just return false. Look, you had it coming, right? So if you have the error message in there, I mean, because this is just a built-in error message from the book. It's not really helpful for this. You should always write code that's completely error-free. Dr. Lockwood, standard. All right. Sure. Make sure you get my good side. All right. Okay, so apply env. This is effectively variable resolution, right? So we're searching for a variable name in the list of scopes that we have, and as soon as we find the most local copy of that variable, we resolve to the value. Now, for the homework assignment, we're supposed to say is binding. Has binding. Yeah, so actually my modification, what I wanted to do for this, in fact, I'm going to go ahead and do it because these error messages are dumb. Because this would have made your homework actually really, really easy. If you come in here, you take those couple error messages out, and then anytime you would have reported an error, just boil down to false. Is this the other one? That's false, right? Lowercase f?
Yeah.
Okay. So then for, what's it called? Is binding? Has binding? Has binding like that. And this is going to be a lambda. What's it taken in an environment and the variable? Or the variable then the environment?
Environment variable.
And then maybe called search var. Something like that. What I would probably do is I would return I want has binding to return true if not apply env search var is not equal to false. So if it gives me something other than false, then this would return true. There is a binding for it. Otherwise, it would return false. Because false is equal to false. Wasn't a binding for it.
Sure.
So you could have written it this way. Written has binding in terms of apply env. Does that make sense? Now, if you weren't going to write it that way, what would you effectively do? You'd rewrite apply env with the only difference being, so I'm going to let's just steal all that code. We'll call this guy has binding to or something like that. Okay, and I'm going to steal the name has binding too because we're going to have to use it for the recursive calls in here. So this guy is going to go through. If we are out of places to look, return false. If we're dealing with an extended env, go ahead and get our 3 variables. If we found the guy we're looking for, rather than give us value, boil down to true. Otherwise, we're going to call has binding to on our saved environment and our search var. Otherwise, return false again. So is that has binding as well? So choose your poison.
Can you scroll back down to the first has binding?
I cannot. It's actually up on the screen above this.
Oh, is it? Oh, that's embarrassing.
Now understand that these are both the same. It's not like, oh, this is the super simple, easy, shortcut way of writing it. We didn't change very much in here, right? We just observed the result of apply env up here, and based on the result, determine whether it found the value or not. Does that make sense? But we had to modify apply env to give us falses rather than the error message, because an error message wouldn't have allowed us to respond to that. So pick your poison, but understand that has binding and apply env are kind of convenient. Well, has binding is kind of a convenience function, probably for error checking, right? If you're writing an interpreter, writing a compiler, right now we're dealing with interpreters. When you go and look something up, before you go to resolve a variable, especially in an interpreter which is running in real time, don't you need to kind of check to see if it's resolvable? Because right off the bat, if something is an interpreter, speed is kind of a secondary priority, isn't it? I mean, we wouldn't be using an interpreted language if we were completely focused on speed. So an interpreted language, the fact that we're making this effectively the same logic call twice, not the end of the world. All right, but we're going to say, look, if there's a binding, then I'll resolve the variable. Then I'll apply the environment for that variable. Otherwise, maybe I'll spit out an error variable not available or something like that. Okay, so that's has binding. Any questions on that? Go ahead.
When you call has binding to again, question
mark. Oh, thank you. Okay, I'll throw this up on Slack. I didn't actually test it, but what could be wrong with it? Okay. Give more informative error messages. The funny thing is I should give that one to you now. Because after I've deleted the error message aspects of our environment. So is this what they're calling a list? Is this the a list implementation? All right, so this one says add to the environment interface an observer called emptyenv and implement it using the a list representation. Okay, so they want us to define an empty env predicate. This guy will take an environment in as a parameter, and we want to return true if the thing we're looking at is the empty environment, right? So we want to start getting used to using cons. Realistically speaking, we would never actually have a null environment, right? The smallest environment would be the empty environment. So I'm going to kind of run with that. So with that in mind, we're going to say if EQV car of env empty env, and we don't even need to condet, we can just return that. So just return whether or not the car of the environment is emptyenv. So our two options are emptyenv and extendenv, right? All right, so that's our predicate for checking to see if something is the empty environment. Add to the environment interface this is what we just did, has binding. Add to the environment interface a constructor called extendenv star and implement it using the A-list representation. This constructor takes a list of variables. Oh, that would be a good one for us to write for a homework assignment, I think. Let's see, a naive implementation of extendenv star from the preceding exercise requires time proportional to k to run. Oh, who cares about performance? It is possible to represent an environment to extendenv requires only constant time. Ah, forget about that one. Okay, so we're going to say one of your homework assignments for the weekend will be 2.10. I'll put that in here. Let's see what else we come upon this guy. Okay, yeah, so here's a procedural representation of our environment, and this guy starts looking like what I wrote last time, where it didn't have the words in there, right? The empty environment, well, here's the, actually that's weird. Define empty environment to be a lambda Is this wrong? Takes no parameters. How can it look for a search bar? We don't have a search bar. Oh, here they're having these guys return procedures. So what does empty environment do? It returns a procedure that takes in a search bar and reports that it's not found because it's an empty environment. So the returned value of this procedural representation of this guy is a procedure, is a lambda expression. Extendenv, similarly, takes in 3 parameters, and it returns a lambda that takes your, a lambda that will take a search var and check for that search var inside of the saved var. So this guy, each environment, each extendenv will return its own little checker to see, is this variable you're searching for available within my environment? Is it, because right now our environments contain a single name value pair and then a new environment. So extendenv gives us, it hands us back this guy right here, which is a function that I can pass a search variable to, and it will ask whether or not the thing I'm searching for is equal to the variable it has. Otherwise, it'll call apply env on the rest of the environment. So what this has done is it's broken up our apply env. It's made extendenv provide us its own checker to check that environment. I'm not sure that's any better. I would say I like it less, but I guess it's a thing. Definitely not going to have you do that one because of the procedural question. Let me look ahead here and see, are they using procedural for everything from this point forward? Okay, so I'm going to make a blanket statement here then moving forward. Anytime a question for the rest of this chapter says do something procedurally, do it in terms of this A list. All right. It's not that the procedural implementation is horrible. This is more of the an interpreter style for environments. So always use this A list from this point forward, at least in this chapter. So until I tell you something different. So then with that in mind, this next section, so we're going to do 2.10 for homework. And then this next section introduces the language of lambda calculus. So we have a lambda calculus expression, which can either be just an identifier. So this is going to be our first programming language that we're writing. Okay, very simple one, but it's our first language. So we have something called a lambda calculus expression that can be either just an identifier, so it'll be a symbol, right? Which, if we think about that in our programming language terms, that's just a variable name. So if we see a symbol, if we see an identifier, that means that's a variable we probably need to apply, a variable we need to go look up. We can have a lambda expression, and their current definition of a lambda expression only allows us to have one parameter. So that is a list containing the word lambda, followed by a parameter list with exactly one identifier in it initially, followed by something that is a lambda calculus expression. The third production is a list containing two lambda calculus expressions. All right, and what this guy is actually mimicking is function name, what we're applying it to. So this is an operator and an operand. That's what that guy is creating. Okay, so our lambda calculus, this is the language of lambda calculus. Now we can start thinking of some other expressions that might exist in here, like variable expressions, app expressions, and what those might mean. But initially, let's just think about the generic language. So let's see, do they give us a... Okay, I think let's do this binary tree one as well. So let's do 2.10 and 2.19. We've already seen some binary trees. You will need to look at, probably look at the example from 2.18. I'm not assigning 2.18, but this gives you an example similar to the binary tree one in terms of numbers. And this is all dealing with recursive data types. All right, so 2.110 or 2.10 and 2.19 for homework. All right, so I got a book, but I will see everybody on Monday.